Welcome to Brain Vision.
So we are going to use df equal to I times dl times b sine phi to calculate the force on a short segment of the coil, and then we are going to integrate over the entire coil to find the total force. Now let's take a look at these two figures. So these are basically sketches that mark the direction of current, magnetic field, and the force for uh, two short segments of the coil on two short segments on opposite sides of the coil. So you can see that from these two sketches that the x components cancel because I and B are constant in these two. So the magnitude of dfx and dfx dash are equal, but they are in opposite directions. So for this part, the net force, which is going to be a sum of these two forces, is going to be 0. And so the net force along y direction, so the net force is going to be the sum of the forces along y direction. So only the y components will add. And this is true for all pairs of short segments on opposite sides of the coil. That means that the net magnetic force on the coil is in the y direction because the x components simply cancel, and its magnitude will be given by f, let's say, and this will be given by integration over all components along y direction. Now let's calculate that. So df, which is net force for, let's say, the short segment one, is equal to I times dl times b sine phi, as I wrote here, and phi is 90 degree because current and magnetic field are perpendicular. So this will just be equal to I times b times dl. So dfy will be equal to df times cos 30 degree. So this is 60 degree. That means we can say this angle is going to be 30. So this is going to be 60. And so this is going to be 30. So this is going to be 30 because 90 degree minus 60 degree, and we do the same and find that this is 60 and this to be 30. So for that, the cos 30 degree comes into account. So this is equal to I times b times dl cos 30 degree. So the total force, which is integration over this value, is equal to integration I times b times dl cos 30 degree. I can see that current, magnetic field, and cos 30 degree, these are basically constants. So we can take them out of the integral, and we are left with integral over dl, and dl is the total length of the wire in the coil. And this dl is gonna be the total length of the wire, which is the number of turns of the wire times the circumference of the coil. And we find the value of r, the radius of the coil, from the diameter, which is given. So now we can solve this, and we see that the value of this force comes out to be 0.444 Newton. And this value is along the along the y direction, specifically negative y. So we can write f vector is equal to negative 0.444 Newton, J cap, which indicates the direction.